Hey guys, today let's look at Nyquist diagram, rough sketching. Now, the solving and all that we have to do to get our Nyquist diagram, those ones are good and fine, but we can actually have a picture, if not an exact picture, but we should know what our Nyquist diagram should look like. At least from if a function is given to us, we should know what this thing should look like. The Nyquist diagram should look like. Now, let's say we are given a function of this form of GW. So we're given a Nyquist diagram of this form. There are 4 laws we need to apply in order to get a kind of a vague picture or a picture, a rough sketch of what our Nyquist plot should look like. Okay, now our Nyquist plots, in case if we don't know, I've stated it in one of our videos. It's actually a polar plot of where your y-axis is now an imaginary axis, and while your x-axis is now what? Real axis. So if you're given a function, let's say 2 plus 2 plus 2j, you look for 2 on your y-axis and 2 on your x-axis. This 2 is representing the one with imaginary sign. The 2 is representing the real number. Then you join the 2 of them. This is a representation of this. So in case we're given 2 plus imaginary 3, it's not going to be what? Here, 3. This point. Graph. So that's for Nyquist diagram. Now, for us to solve it, most times it requires that we have to start separating the imaginary from the real, and also finding the polar plot of it. That is, even finding the magnitude and its phase angle and all that. But in this step, you can actually create a picture of what the graph should look like. Okay, now all these things as well can be done with your MATLAB, but it's actually good to also have idea on how to also actually draw it. Now, for us to draw this, the first law we follow, or rules we follow, is our, first of all, you look at your words, at your n. Look at your n. Focus on your n now. Your n can be 1, 2, 3. Sorry, I tell you now. Can be 0, 1, 2, and what? 3. 0, 1, 2, 3. Right? Then when it is 0, definitely you know that what it means is that this wasn't given to us. So in a case where JW that doesn't have any T1 or any stuff again attached to it, just J1 on this, that we don't have any J1, you know that your N is what? 0. Now, if your N in this case is 0, if it is 0, you are to start from the positive side of your real angle, and you're going to be starting from the line, and you'll be ending at the what? All of them will definitely end at what? The origin point, as omega tends to what? Infinity. So the idea here is when your n is 0, or there is no JW that is on its own, it means that your graph is going to start from a particular line here, from a particular just a particular point on this right side of your real axis, to start from here, and definitely, I don't know how many ways it can go, many turns, but definitely you should end at what? Your origin point. Now the distance from here to here is your what? Your k. Should be your k. This is for what? 0. Now for 1, on the other hand, we call this the fourth what? Quadrant. So from the fourth quadrant, you start making your curve. But for 1, on the other hand, you have to start from your third quadrant. your what third quadrant around this place, but you won't start from the imaginary line or from the real line. Instead, you just start from any points. You should just any place in this within this space, within this third quadrant. Just start from there, and definitely to still end at what your what your origin. No matter how many turns it to take, it can take more than one turns. I will get to that. That will be one of the rule. Now, if it is one, let it start from the word third. If it is zero, from the fourth quadrant. If it is third, from the third what quadrant. But definitely everything at all times should end at what zero. The same thing for your two. Your two, on the other hand, you're going to be starting from your second quadrant. The only one that is that was touching the axis is only for zero. The rest doesn't touch the axis. So you're starting from the second quadrant for when n is 2, and then for when n is 3. For when n is 3, start from your first quadrant. Now, these are the rules for the for the first one. When n is 0, start from this. When it is 1, start from third. When it is 2, start from second. When it is 3, start from first. So you can actually say this, start counting from this order. 1, 2, 3, 0, 1, 2, 3. So this is for 0, this is for 1, this is for 2, this is for 3. So you can know how to memorize it. So in my own way, you can just make it like this. You can use this form to actually represent it. 0, 1, 2, 3. With 0 be the only one that starts from the real line. The rest doesn't. Okay, now moving over to the second rule. Now our second rule is that no matter what whatever you're drawing, you should always end at the origin point. That's what I've been saying even when I explaining this one. End at origin. Now the third one is that your k doesn't actually have much impact in your diagram. Only what it does is just to it only increases and decreases the size of your diagram. But when you don't know the value for k, or when you don't when you're making a rough sketch, size is not something to consider at that point. But only when you consider it, when you kind of make small indication of what your k is for your 0. But in for 1, 2, 3, not often needed in this rough sketch. So our k is just for scalability. That is its function. To scale, when I say scalability, that is to increase or to decrease. It determines how big or how wide your graph will be. And then lastly, is for your the last one is for your T1, T2, T3, go. But in this case, since we started at T2, let's work with that. You can also have T3, T4, and the rest of them. Now your whether T1, T2, T3, it tells you the number of turns your graph is meant to be having. When I say the number of turns, in a case where you are for this, let us say we are drawing for this one, this particular one that only has one T1 to T2, we're going to be having about 2 turns. If we had only just T1, that's if this one wasn't here, we have only 1 turn. When I say 1 turn, is like it will not pass more than 1 quadrant. So if it was only just T1, so let us say we are trying to use that of 1 when n is 1, and we're starting from here. When it's just only just T1, we don't have T2. When it's just T1, we will just end at the origin point here. But when T2 is given to us, we will enter the second quadrant and still end at 0. The same thing when T3 is also given to us, the same thing also happens. You enter the first quadrant this time around and still end at at origin. So this is just for a rough sketch. It's not the exact picture, but a rough sketch. So it will guide you on how your graph should look like. So we'll be taking some examples Okay, so the question says sketch the Nyquist diagram for the system with open loop transfer function g of s h of s is equal to 1 over s times 1 plus st. Now this is a transfer function given to us. We have to now convert it into its should I say complex frequency form. So complex frequency domain. So we have JW. This is what I mean. Converting your S to what? JW. Right? So from this now, we know that our N here is what? 1. It is 1. That's the value of what your JW is. It is what? 1. Now our T here is also what? 1. So we'll be making using only what? 1 quadrant. So what this means is that our graph is going to be starting from here and it's not going to be leaving this quadrant and ending exactly at this what point. This is where omega tends to what? Infinity. While here is where omega is what? 0. So it starts from infinity. We don't actually know the value of this point. So this point is actually infinity. When omega is 0, it starts from infinity. And when omega is now infinity, it starts tending towards what? 0. So this is kind of a rough sketch on how it should look like. Remember, here is your imaginary axis and here is your what? Real axis. So this is a rough sketch. That's this one. Let us try another example. Okay. Now let's try for this one. Again, it's called a rough word sketch. So accuracy is not our strong point here. So sorry, this is the wrong presentation. Now for our G converting to what? Complex frequency domain, we have 1 over GW or what? Square 1 plus S, okay, JWT1 and 1 plus JWT2, right? Now from here we know that our N is what? Is 2. Our N here is what? Is 2. And our T, we're having what? T1 and what? T2. That means we're going to be going we're going to be entering we're going to be making use of what? 2 quadrants. Okay, then our K here is 1, but we don't we need it since we're talking about rough sketch. So here being your real, here being for your imaginary. Now since N is what? 2, definitely we're going to be starting from what? Here. So we'll start from this point. Now we're not going to be just terminating it directly here. Since we're now having T1 and T2, it means we're going to be making it of what? 2 quadrants, and then finally we terminate it at this point. So at this point, omega is what? Infinity. At this point, omega is what? 0. As easy as that. Let's try another example. One more example before we go. Okay. Now, converting to our complex frequency form. The conversion is just in place to see s, replace it to what? JW. That's all. So 1 plus JW C1, you close the brackets. 1 plus JW C2, you close the brackets. And 1 plus JW C3, close the what? Brackets. Now, from here, we know that our N is what? 0. There is no JW on its own. That's 1. Then we have T1, T2, and T3. That's we're going to be making use of what? 3 quadrants. Now, since we're starting from what? Our N is what? 0. Since our N is 0, that means we're going to be starting from a point on the what? Real axis on the right hand side. We'll pick from here. Then we start moving. But since we're having about 3 T's, I'm going to be making use of what? 3 quadrants. So 1, 2, and 3. So at this point, W is what? Infinity. And at this point, W is what? 0. And the distance from here to here is what? K. So as you can see, it's quite easy. If you just follow the rules, it's quite easy. Just know which quadrant you're meant to start drawing from. Then for your T1, T2, T3, tells you the number of quadrants you're going to be passing. So when it's totally just T1, we will just we'll terminate it here. So you do not pass this quadrant. This quadrant, you do not pass this quadrant. When it's T1, T2, this quadrant or this quadrant, it will just terminate itself within this quadrant. Just you make the use of these 2 quadrants. Now this is now and having what? T3. 1, 2, 3. So that's all for this video. Subscribe, like, comment, and share. Amen. Keep being the best version of yourself. See you guys in the next video. Goodbye.